This is the sorting algorithm the pros actually trust, the one hiding inside your programming language and your database. And the trick behind it sounds almost lazy. Don't sort the big messy pile at all. Instead, you split the pile in half, then split each half again and again until every piece is a single card. Because one card is already sorted. That's the whole secret. Then you play it backwards. Merging two already sorted stacks is stupidly easy. Just take the smaller top card each time. They fall into perfect order, with almost no thinking. Now let's watch it run for real, on this array. Watch how the splitting and the merging mirror each other. First, the divide. We cut the array straight down the middle, into two halves. Then we split each half again and again, until every piece holds just one number, and the single number is already sorted by itself. Notice we haven't compared anything yet. That's the point. Now the clever part, merging the pieces back together in order. This is where the real sorting happens. To merge two sorted lists, we drop a pointer at the front of each and compare what they point to. We take the smaller one, place it, and slide that pointer forward. Watch. 2, then 4, then 5, and finally 8. We repeat until both lists are empty, and out comes a perfectly sorted piece. No swapping, no shuffling. Now run that exact same merge everywhere. Each pair of singles becomes a sorted pair. This bottom-up rhythm is the entire algorithm. So if it's clicking, subscribe, because this one shows up in interviews constantly. Merge those pairs into sorted groups of 4. Then one final merge combines the two halves into the finished array. Fully sorted. 1, 2, 3, 4, 5, 7, 8, 9. Split, then merge. That's the whole trick. Here it is in code, and it's shorter than you'd think. Just two functions. The base case first. If a piece has one element, it's already sorted, so we return it as is. Otherwise, find the middle and recursively sort the left half and the right half. mergeSort calls itself. That's the recursion doing the splitting for us. When those calls come back, both halves are sorted, and we merge them. The same trick as before. First, merge makes a temporary array called TMP. We give it r-l plus 1 slots, exactly enough room to hold every element in this section. Then we set up 3 pointers. I starts at the front of the left half, j at the front of the right half, and k at the start of TMP, where the next value goes. This loop runs as long as both halves still have elements. The moment either side is used up, we stop and clean up the rest. Inside, we compare the two front values. If the left one is smaller or equal, we copy it into TMP and step I forward. Otherwise, the right one is smaller, so we copy that and step j forward. Either way, k moves on, and the loop repeats, always taking the smaller of the two fronts. When the loop ends, one half is empty and the other still has leftovers. This first cleanup loop copies whatever's left in the left half. Here, it's already empty, so it does nothing. This second loop does the same for the right half. Its 8 slides straight into TMP. Only one of these two ever runs, whichever side wasn't emptied. Finally, we copy TMP back into the original array, starting at index L. That section is now fully sorted, and that's the entire merge. In C++, it's the exact same code, pure logic, not language tricks. In C, only the array syntax changes. In Python, the same logic again, just without the braces or semicolons. So why do the pros trust it? Look at any single level. Merging all its pieces touches every number exactly once. That's order n work per level. And since we halve the array each time, there are only about log n levels. Multiply them and you get a rock-solid order n log n. Best case, average, and worst case every single time. Quicksort can't promise that. The only price is a little extra space, order n. So next time your language sorts a list in a blink, you'll know the trick underneath. Split until it's trivial. Merge until it's sorted. If this finally made mergeSort click, subscribe. And tell me in the comments which algorithm I should break down next.